Hello everyone. So this is problem number 5, part 2 from my final exam. And before we start, I just wanted to pitch the link in the description. I do coaching calls, so if you have any math problems, ask me. Anyway, now we're supposed to find out if this integral, which is the integral from 1 to infinity of arctan of 1 over x minus arctan of 1 over x plus 1 with respect to x, and we're supposed to find out if this converges or diverges. Okay, so generally when you have these kinds of integrals and you're supposed to find out if they converge or diverge, and you have weird functions, the best thing generally is just to do a Taylor expansion. Plain and simple. So, because this thing here tends to infinity, then 1 over x tends to 0, of course. So you could either make this a bit more clear and use a variable substitution, or maybe that wouldn't work there. No, I'm sorry, it wouldn't work. So you can just state that, okay, this thing here tends to 0 and this tends to 0. So we do a Taylor expansion of arctan at x, arctan x, when x tends to 0, but instead of x we have 1 over x and 1 over x plus 1. And just try to find out kind of like what it looks like. That's the best way to describe it. So we know that this thing here inside, I will call it a star. If we Taylor expand star, then we would get, okay, so we get 1 over x, because the Taylor expansion of arctan of x is x minus x to the power of 3 over 3 plus x to the power of 5 over 5 and so forth. So this would just be x. I'll do two terms, just it doesn't. You will see my point soon. So then, okay, so we have then minus this to the power of 3 over 3, so therefore it's just 1 over 3 x to the power of 3, and then plus some big O term of 1 over x to the power of 5, of course, and then we have minus this over here, so then we just have x, so that is 1 over x plus 1, and then we have plus because it's minus, so then it's 1 over 3 times x plus 1 to the power of 3, and then some big O of 1 over x plus 1 to the power of 5. Yeah, as I said, it says over to the power of 5. I'm sorry if I'm writing too small. And okay, so what the fuck is this? Well, when x tends to infinity, what will the most relevant parts be? Well, it will obviously be this and that. They will be the greatest. You could say that, the greatest. So okay, is it x 1 over x minus 1 over x plus 1? And as this is kind of the same thing as in the last integral. So what is this? This is just 1 over x times x plus 1, right? So we know that, okay, when x tends to infinity, this thing will sort of tend to this thing here over here. So that would mean that if we could find the limit, as x tends to infinity of star, that thing over there, divided by, because here we have a big division sign, then here we have a small one. So 1 over x plus 1, which is just, of course, the same as moving this up there. If we can find this limit, then we know, due to the limit comparison test, that the star has the same convergence or divergence as this expression here. So if this one converges, then star also converges, and the same thing and the opposite is true also. So what is this then? Okay, so as I said, we move that up. So we have the limit from x tends to infinity of x times x plus 1. Sorry, no, we should do this. We should do this instead. We just keep the division signs. So we have, yeah, I can move. So we have 1 over x minus 1 over x plus 1. That was what we got to. And then we just plug in star here. And that is this whole thing that goes on top of there. So what do we have? Okay, well, okay, here we have the same thing as there, obviously. And then after that, we have a bunch of, okay, so 1 over x to the power of 3 divided by this thing here, meaning that we multiply by just this, and this is a second degree polynomial, and this is a third. So therefore, we would still have a 1 over x something. So essentially what I'm saying is that everything except these two divided by these two will disappear. And what we will have left is just this divided by itself. So it's just 1. And therefore, we know that this thing here has the same convergence as the integral of this, which we knew earlier was just 1 over x minus 1 over x plus 1 dx from 1 to infinity. So we know that this thing here, if we were to integrate this, of course you could just instead compare this with the Basel series, because this is just, no, sorry, you could not. Yes, you could, exactly. Because this, we know, of course, that this is just less than 1 over x squared, obviously, when x is positive. So, of course, you could just say that this is less than Basel series, and obviously that converges, so you would kind of be done. Or you could use the other thing, so then you would have, okay, so the integral of this is then ln x minus ln x over 1, so therefore that is the same thing as ln of x over x plus 1 from 1 to infinity. And what is that? Well, it's just, okay, we plug in 1, that is 1/2. And then infinity, you get ln 1, which is a 0. So this also, you could use this way to show that it also converges. So yeah, that was everything done. So yeah, conclusion, it converges. Yes. So now let's move on to the third one. Check out the link in the description.